All right, moving on to 7.2. This should be a lot shorter than 7.1. Sorry, I didn't realize I had that one go so long. Okay, so we're just talking about even and odd functions and what makes an even and odd function. So I want you to look at these three functions here that are even functions and see if you can kind of recognize what makes them an even function. And one of the things that they have that says what an even function will be is that they are symmetrical. If I put a mirror on the y-axis, I would have a mirror image. Or if I folded this graph on top of itself, I would have the same picture to the left and to the right of the y-axis. So we say that even functions are symmetrical. And the way that we word it is, they are symmetrical about the y-axis. And what that really means is if I folded a piece of paper over that y-axis, I would have exactly the same picture. It would be symmetrical. It would be the same. If something is odd function, you would think, okay, well, that's going to reflect across the x-axis, Miss V, if that's odd. But it sort of doesn't, sort of doesn't. It actually is if you took it should kind of that you're rotating it around. So it is symmetrical, but what we say is that it's symmetrical about the origin. And it's like you're rotating it. This is the best one to see it on. If I took this circle, this little half circle, and I kept adjusting it over and over and over, eventually 180 degrees later, it would land on this part over here. Okay. So what we say is that odd functions are symmetrical about the origin. So it's really just a 180 degree rotation around the origin. Okay. So let's just look at these three down here and decide whether they're even, odd, or neither. And I will tell you, because if they don't fit into one of those two, then they're neither one. They don't have to be even or odd. So the first one, if I had a mirror right here across the y-axis, all of my outputs line up exactly. So this is going to be an even function. Here, well, let's see, I've got it's going down a little bit here, but going way up here, so I know it's not even. And then if I took this and rotated it around 180 degrees, it still wouldn't match what I have here. So this one's neither. It doesn't have to be. Functions do not only fit into odd or even. There's definitely some functions that are not either one. Okay. And then our third function, you can really just cut this down since this is a repeating pattern, right? This is actually a sine function that you can look at just one little section. So let's just look from here to here even. Okay. And let's see what that did. And if I took this little part of a curve here and rotated it around 180 degrees, it would end up here. So this is an odd function. Okay. So we can actually practice graphing now, coupled even and odd. And what you're going to do is you're going to take all of these points, but you're going to flip them over to the other side of that y-axis. So this is where my point is bending. Here I've got, what, -1, 2. So I need it to be over here, right? So there's one point I can put in there. I've also got, let's see, what else do I have? I have this one down here, which is a little bit past 2 and down a little there. And then I've got 1, 2, 3 and up 1, 2, 3 almost. 1, 2, 3 and up 1, 2, 3. So it would look something like this. Okay. So it reflects across that y-axis. Odd means that it's kind of rotating around here. So if I took this point and rotated it around here, it would end up here. If I took this point, it would now, instead of being, and what you have to think is it's kind of doing a diagonal move. That's what it's doing. If you look at the odd function up here, it's kind of a diagonal move, right? It's moving across and flipping. So it's kind of a reflection and a rotation. So this point would now be over 1, 2, and down, let's see, down a little bit here. Then here we would have, this is going to be over near this one, so that's over 3 and up, what, almost to 4 here. So it's going to go something like this. Okay, so if I took this piece and moved it over here, they would line up on top of each other. Okay, good. So we can check these algebraically also. And we're going to check to see if they're odd or even, but there's actually an algebraic way to say that. So if we look at our pictures, we notice that for even functions, our f of x, our outputs were the same as when we changed our inputs to the negative. When we flipped them over the y-axis, think about a parabola. When I put in 1, I get into a quadratic equation. 1 squared is 1, but negative 1 squared is also 1. So when I change that input to negative, I get the same output. Okay. For odd functions, the whole thing is negative. It kind of flipped the entire sign of the output of my function. So let's look at that last one that we did. For our odd function, first I had negative 1, negative 3, and I ended up with 1 and 3. So both of those signs changed down here. I had negative 1, negative 3, and my rotation I got 1 and positive 3. So both of those signs changed when we got that. Okay. Actually, I need to adjust my formula a bit. When we change the sign of our input, we got the opposite output. Okay. So how are we going to check these to see if they're even, odd, or neither? So what we're going to do is we're going to plug in negative x and see if we get the same output or the complete opposite output, meaning all of your signs are opposite. So instead of x, I'm going to plug in negative x cubed plus 5 times negative x. And then we just need to simplify and see what we end up with. So negative 2, and then we have negative x cubed. Whenever I have an odd numbered exponent and a negative base, that answer is going to be negative. So negative x cubed is negative x cubed and minus 5x. I have a negative times a negative, so I get 2x cubed minus 5x. So if it's even, I know that my output is going to be the same, which it's not. And if my signs are the opposite of what they started to be in the original function, then I know it's odd. Well, I went from a negative 2x cubed to a positive 2x cubed, and from a positive 5x to a negative 5x. So this is going to be an odd function. Okay. So let's try the next one. And it's kind of a hint if something you have up here is an odd number. Not always, but that you have an odd exponent and another odd exponent that's next to the first. On your second example, we do have an x squared, but then we've got an absolute value. So let's see what happens here. And we're going to do the same thing. We're going to plug in negative x. So we would get negative x squared plus 1 over absolute value of negative x. So negative x squared is still x squared plus 1, and the absolute value of negative x would still be positive x. Sorry. I was going to rewrite that when I didn't need to. And that indeed matches what we've got in our original function. So this is an even function. The output stayed the same even when I had the opposite input. Okay. So let's check this one down here at the bottom. We're going to do the same thing. This one, I'm not sure how that's going to turn out because you've got an even and an odd function going on. So let's see. We're going to do the same thing. So we have f of negative x. So that would be negative x to the 4th over negative x cubed. Make sure that's within your parentheses, minus 1. All right, so let's just kind of simplify that and see what we end up with. Negative x to the 4th is positive x to the 4th. Negative x cubed would still be negative x cubed minus 1. So let's see if our signs are the same. It's going to be even. So I've got positive x to the 4th, positive x to the 4th. Oh, I've got x cubed and negative x cubed, and then negative 1, negative 1. So this is a problem. So we know it's not an even function. So not even. Okay. And then if it's the opposite, then we're okay. So we could check a couple things. We could see if this is the opposite, which it's not. If both of these are the opposite, then we're okay, but only The x cubed is the opposite sign, so that's also. So it's not odd either. So it is neither even or odd. Okay, good. That's a nice short 7-2.